Hi, welcome to a new video about sine law and cosine law. This video will talk about the basics. What type of triangles use which law? How do we label the triangles to work with the formula? And how do we solve for both angles and sides for both cosine law and sine law? Why do we need sine law or cosine law? Well, that's easy. SOHCAHTOA is what we learned in grade 10, and with SOHCAHTOA, we need a right angle triangle so we can label our hypotenuse, our opposite, or adjacent, and use a sine, cosine, or tangent ratio. If you need more information about SOHCAHTOA, please see one of my previous videos. So if we're looking for an unknown side or angle in a triangle that's not a right triangle, we simply don't have the tools to do it. That's why we're going to use sine law or cosine law, depending on what information we're given and how we're able to label the triangle. All right, let's have a look at sine law. First of all, let's look at the triangle. Notice for the first time it's not a right angle triangle. We have an acute triangle in this case. Let's look at how we label triangles in sine law and also later on in cosine law. First of all, we use capital letters for our angles, and then we use corresponding lowercase letters on the sides that are opposite. So you can think back to SOHCAHTOA and think back how you label the opposite side, and it's the angle directly across from the side. Now, the thing I like about sine law is I like to use what I call a loop. And in a loop, we have an angle and a side. We have an angle and a side, and we have an angle and a side. The nice thing about each loop is each loop makes a formula. So let's go back and look at the top here. So if we look at the first loop, A, the sine of angle A and the side of A are related. So oftentimes in my class, I'll write the sine of angle A over little a. But guess what? It's a ratio. It doesn't matter. And then we can do the same for sine B, which is sine B over little b. And I ran out of room, but it's also equal to sine C over little c. When we're using sine law, we only need two ratios. We're going to have three things that we know and one unknown to solve for. So in this case, we can either solve for a missing side or a missing angle. All right, let's look at the basics for sine law. First of all, let's go through a few of the steps. Solve for all the angles, which means in this case we have angle C missing. So we have to figure out what's 42 and 75, and in this case it's 63 degrees. So we just pop in 63 degrees here. Draw the loops. One needs both an angle and a side, and the other needs one unknown. So in this case we need to solve for an unknown, so how about we solve for little b. And here's one loop, and here's two loops. Fill in the formula and use equivalent ratios to solve for the missing side. All right, notice how we're going to start to build the formula. I've filled in the 63 degrees, which is our missing angle, step one. I've drawn my two loops. One has an angle and a side, which is the C, and one has one unknown and an angle, which is B. Each loop makes part of the ratio, so that makes it easy. So the sine of 63 over 22 is the first loop, and the first part of the ratio is equal to the second loop, which is the sine of 75 over b. Now here's a mistake that a lot of people make when they solve the formula, is they do the cross multiplying wrong. So look for a third loop. The third loop is 22 times the sine of 75 degrees, and then you divide it by the missing piece, which is the sine of 63. Make sure when you put this in your calculator you do 22 times the sine of 75 degrees equals, divide it by the sine of 63, and you will get 23.849, and we can round up to 2 decimal places is fine, and the units check is centimeters, and the answer is 23.85 centimeters. Please make sure you're in degree mode, otherwise your answers will be incorrect. And that's as simple as it is for solving a missing side using sine law. All right, here's your chance to try sine law. Notice this one doesn't have any label, so that would be a great place to start. So you can label them in any order. We can label this one as A, B, and C, little a, little b, little c. So now what we want to do is check to see if all angles are solved. Oh, guess what? They're not. So let's go and solve for the missing angle first. All right. If you did the math correctly, which I think I did, you'll find the missing angle is 68 degrees. Now it's time for us to look at figuring out how to use the formula. So that's the next stage. What we need to do is draw our two loops. One that has everything in it. Well, A looks pretty good. It has a side and it has an angle, and C has the unknown and the value that we need. So now it's time to use each loop to set up a formula. So we'll use the sine of 63 degrees over 10. Remember, every loop is a formula, is equal to the sine of 49 degrees over the unknown. Remember, we need our third loop here. Our third loop helps us to build the formula. So that's the 2 we multiply. 10 times the sine of 49 degrees over the sine of 63 degrees. And if you do that correctly, you should get, with rounding, 8.47 centimeters. So there's your second example on how to find a missing side using Sine Law. All right, let's look at using Sine Law to find a missing angle. Notice this triangle doesn't have any labels, so let's start with the basics, and we'll call this A, and this would be little a, and call this B, and little b. All right. Notice our unknown now is an angle, so a little bit different than the last time. So first things first, let's find our loops. Here's a loop with A, which has our angle and our side. And here's our loop with B. It has a side, but this time a missing angle. So now we can write out our formula. Remember, every loop's a formula. So the sine of 63 degrees over 10 equals the sine of our unknown angle B over 8.47. So now what we're going to do is find which one has the unknown in it, which is in sine B, and we'll use these two to multiply and this to divide. So sine B is equal to 8.47 times the sine of 63 degrees all over 10. Now, notice that you have a sign here, so you're going to get a decimal answer. You'll have to do second function sine, and if you do that correctly, you'll find out that this angle is 49 degrees. So that's the only extra step you have to do in finding a missing angle, is use second function sine. All right, now it's your turn. You can see in this triangle we have our missing angle here, x degrees, and we have a known angle, 29 degrees, and two known side lengths. Again, always start with a quick label. You can call this A and little a, and B and little b. The name doesn't really matter. And now we draw our loops. So now there's the loop that we need that has both the angle and the side, and here's the loop that we have that has one of each. So now we build our formula based on each loop. So the first loop is sine of 29 degrees over the side length of 11 equals the sine of some unknown angle, x over 20. And now we solve for our unknown, again, sine x degrees equals, if we're looking for our third loop, which is here, 20 times the sine of 29 degrees all over 11. And don't forget, the very last step will be second function sine, and if you did that correctly, I got 61.8 degrees. So there you have it. There's Sine Law, finding a missing side, and finding a missing angle. All right, let's talk about the cosine law now. Have a look at the formula. A squared is equal to b squared plus c squared minus 2bc cos A. It looks a little bit scary, but it's actually not too bad. So a squared is the length of the side opposite angle A, as usual, and we're trying to find that. So we need these three pieces of information to help find it. Now notice how this looks like a little hat or a little brain, depending on how you label it. So that's the organization of the triangle. You need an angle surrounded by two sides. And if you're thinking about congruency, that would be the rule SAS. So you need a side, angle, side for that to happen. Then you just fill in the information. So b squared plus c squared minus 2bc cos A. make sure in your calculator you do all of this as one unit, and then you add it on to b squared plus c squared. Now let's look at one more thing before we move on. You'll see in textbooks and other websites and other videos even that a lot of people relabel the triangle and they'll have formulas for b squared equals and c squared equals. Well, I like to cheat. I don't use these very often because I just relabel my triangle. So whenever I'm looking for a side, even if it's labeled as a b or a c in the other way the textbook has given it to you, I just cross it out, make the angle I have a, make the side I'm looking for a little a, and I use this one formula. Let's have a look and see how it goes. All right, let's have a look at this cosine law using the formula. And let's look at this triangle that we have. The first thing you want to look for is the pattern. Does it have the SAS or the hat? Well, this one clearly does. But what's also wrong with this one? Well, in my opinion, it's labeled incorrectly. So let's get rid of P and make it A with little a across. That's the unknown we're looking for. And these can become B and C. Nice thing about cosine law is really only A matters. Now, the next thing is always write down the square root while you're working through the question, because oftentimes it's a long formula, and when we get to the end of it, we forget to take the square root. So always put that down as a friendly reminder to yourself. So let's figure it out. A squared is equal to 13 squared plus 4 squared minus 2 times 13 times 4 times the cosine of 70 degrees. I apologize, it doesn't fit on one line. So please put this into your calculator in one go, and then add on 13 squared plus 4 squared, and you should get the square root of 149.42, and that is equal to 12.22 approximately. So 12.22 is the length of side A. That's really all there is to cosine law. Make sure you find your SAS or your hat, you plug it all in correctly, and you get your correct answer. All right, here's cosine law round 2. Again, we're looking at the SAS relationship. Is there the little hat? Yes, there is. Is this one labeled? No. Well, that's great as far as I'm concerned because I want to do my own labeling. So I'll make that A, that little a, this B, and this C. But remember, B and C don't really matter. Let's fill in our formula and see what it works out to be. All right, let's fill in our formula. Now notice that we have an angle of 35 degrees and our two side lengths are 400. So it's 375 squared plus 400 squared minus 2 times 375 times 400 times the cosine of 35 degrees. I apologize, I can never get it in one line. If you plug that into your calculator, remember to do this very carefully with the second half. Cos 35 times 400 times 375 times 2, make it negative, add 400 squared, add 375 squared. You should get the square root of 54,879 and 37.37, and the square root of that is 234.26. In this case, that is meters. So just be very careful when you're plugging this into your calculator. Please do it until you get it right. And that's really all there is to cosine law. Find your three parts, plug them into your calculator, use your calculator correctly, make sure you're in degree mode, and please don't forget to take the square root. All right, let's look at the last use of cosine law. It's finding an angle. Now, the cool thing about this is you can find an angle when you're given three sides. So notice that there's no other angles given. There's no two angles given to find the third one. We can't use SOHCAHTOA. We can't use sine law, so we have to find another way. So if you look at the formula for cosine law, you'll notice that there's a cos A tucked in at the end, and we use that in the last couple of slides. Now, we can isolate the variables for this and find out that cos A is actually equal to A squared minus B squared minus C squared, all divided by minus 2BC. Don't forget, when you use this formula, the very last piece is to do second function cosine of your answer and that will magically give you your angle. All right, let's have a look at applying cosine law to a triangle. So here's a triangle, has sides 7.4, 11.6, 15.2. We'll just call it U for units. It can be whatever unit you want. We want to find the value of A, so we're going to use the rearranged formula for cosine A, and then we're going to label this as A, B, and C. And now it's just plug and play. We put in our 11.6 squared minus 7.4 squared minus 15.2 squared, all over in your calculator in brackets minus 2 times 7.4 times 15.2. Now, remember, you have to use second function cosine of your answer. And when you do that, you get 47.75 degrees, or you can round up to 48 degrees. Only things you have to be careful of for this one is making sure you square everything on the top and that you have a really big bracket on the bottom to capture everything, or you do it in two parts. Try not to use your decimal places or your answers could be a little bit different. That's it. That's using cosine law, given three sides to find an angle. All right, let's have a look at finding one last angle. We're going to try to find angle A, which is right here. And so therefore we know that this is little a, this should be capital A, and this is B and C. So again, we're using the cos A formula. Don't forget to use second function cosine at the very end to find your answer. So here we go. A squared is 16 squared minus 9 squared minus 19 squared, all over minus 2 times 9 times 19, all in brackets in your calculator. And I get 57 degrees. So there you have it. The key thing for cosine law is always label your triangle correctly and always make sure you do the final last step. In finding the side, it's a square root, and in finding the angles, it's taking the second function cosine. So when I teach sine law and cosine law, the next natural question is, what about tangent law? Well, tangent law doesn't exist. So unfortunately, the tangent has a big sad face. So tangent only exists when we're using SOHCAHTOA in right angle triangles. You cannot use tangent for a not right angle triangle. So there you go. There's no tangent law. All right. You'll notice in the textbook that we're using that they split up the chapters into acute trigonometry and obtuse trigonometry. But when I teach it all together. Here's why. If we're looking at an acute angle, we know by definition that all angles are less than 90 degrees. If we're looking at an obtuse angle, at least one angle is 90 degrees. But guess what? When you're drawing loops for sine law, or looking for hats for cosine law, it doesn't matter if it's an acute triangle or an obtuse triangle, the laws are applied the same. So sine law and cosine law, they don't discriminate against acute triangles or obtuse triangles. So there's the quick 1-2 of sine law and cosine law. So for sine law, make sure you find two loops, one that has the angle inside and one that has one of the unknowns. Please set up the ratios correctly. Sine A over little a equals sine B over B. Cross multiply to find the unknowns, and don't forget to do second function sine to find the missing angle. Cosine law, always look for the little hat on top of the triangle. It's a side angle side combo. And remember the second step, either square root to find the missing side or second function cosine to find the missing angle. And never forget, there is no such thing as tangent law. Thanks for listening. All right. Let's have a look at the last piece of the puzzle. Which law should you use? Well, you have a right angle triangle. You know the only thing you can use is SOHCAHTOA. But wait, there's more. You can also use sine law. So the right angle triangles, you can also use sine law. Easiest way to approach it. So if you have these three things, a side, an angle, and a side, that would be cosine law. All right, if you have two things that you can put in loops, what law is that? Sine law. If you have three sides and you have to find an angle, what law is that? Cosine. Best use of cosine law is to find a missing angle given three sides. And last but not least, if you have a different arrangement, even if it's obtuse, you can still use sine law. So there you have it. Make sure you can know what law to use, and you have three choices: SOHCAHTOA, sine law, cosine law.